One more quick video, we're going to look at an actual physical quantity, an actual, graph of a physical quantity and use the power rule to figure out its velocity. So let's take a look. Let's say I have a function s of t. Oops, I don't know why I am writing in a highlighter. There we go. S of t equals, um, let's do 20. So it starts at a position of 20. Um, plus 15t minus 5t squared. So if you were thinking about this from a physical standpoint, you might remember x final equals x initial plus v initial t plus 1/2 at squared. So this function, just because of its form, has an x initial of 20 meters. It has a v initial of 15 meters per second, and it has an acceleration of negative 10 meters per second squared. Now, we'll review all of that, so if that's not totally obvious, don't worry. You can also just think of this as a random quadratic function. But this is kind of like you're standing on a cliff. I throw something upwards off the cliff, and it's going to go up for a little bit and come back down. That's what this function is. And, we have other equations that will describe the velocity and acceleration of this, but it's really helpful to use calculus and just analyze it. So let's say I wanted to know the function for the velocity of this tossed object. I would do my ds dt is v of t. And now when you have sums, so you have like three things here, another rule is that, and you could prove this in a very straightforward way. It's also proven in the appendix of quick calculus. Um, as you go through, when you add two terms, you just differentiate each term separately as if it's its own function. So v of t is going to be d by dt of 20 plus d by dt of 15t plus d by dt, I'll do it this way, of negative 5t squared. I could have just subtracted as well, but I'll put the negative in there. So let's apply the power rule. We know that velocity as a function of time, d by dt of 20 is just 0. It has no slope. We also know d by dt of 15t. Remember, power comes down in front, which is 1, and then we reduce the power by 1. So that's just 15. And then d by dt of negative 5t squared, we saw before was negative 10t. The 2 jumps down and multiplies the negative 5, and then the 2 becomes a 1. So v as a function of time is 15 minus 10t. Now you might remember the other equation from the big 2. Velocity as a function of time is equal to v initial plus at. It's just the definition of acceleration. And we saw our v initial was 15 meters per second, and our acceleration was negative 10 meters per second squared. And so you can see how the physics is popping out. We'll do a little bit more with higher order derivatives next class because we could actually take the derivative of this and that yields something interesting too. But I wanted to give you an example of how quick you can do this calculus. Again, we derived a bunch of equations for this quadratic, so we didn't need to do calculus. But let's say you had something crazy like s as a function of time is equal to, 6 minus 5t squared plus 20t cubed. You could certainly have a position of an object described by that function. We would not have physics. We would have run out of physics to be able to do that, but now with calculus, it's a snap. So I hope this was helpful. You're going to have some practice problems, and we'll talk more on Wednesday. See you later.